This type of question is indeed very common if you go through the past exam questions. It checks your understanding of the various different organic chemical reactions that you are expected to know, and also your ability to look at logically what you need to start with to produce something else and through using which reaction. That's the essential basis to these questions. Okay. Says complete the following reaction scheme by naming and drawing the structural formula of each of the compounds A through to F. Okay, there. All these different ones here, including any necessary conditions needed to bring about each transformation. Okay, now we are starting off with a certain compound here, and you do something to it, and then we produce the sodium salt of propanoic acid. But that's not the only product. Doing reaction 1 with this substance produces the sodium salt of propanoic acid as well as something else. Now, this is the important part about understanding how to do these questions. So your mind has to start to think, now, what sort of reaction do I know about by which I can produce the sodium salt of an alkanoic acid as well as another organic product? And one such type of compound that you know about, which produces the sodium salt of an alkanoic acid and another organic product, that is if you start with an ester. So A, therefore, must be an ester of propanoic acid. And this reaction 1 must be warming with aqueous sodium hydroxide solution to bring about the hydrolysis of the ester linkage under base conditions. Okay, so this other compound that you get, the compound C, we can in one step convert it to chloropropane. Now, chloropropane is a haloalkane. So what type of compound is it that you know of from which you can make a haloalkane in one step? That's an alcohol, and in one step it produces chloropropane. So in reaction 3 we can use thionyl chloride, which is SOCl2 or PCl5 or PCl3, and since you produce 1 chloropropane, the alcohol concerned must be propan-1-ol. Okay, we've seen those sorts of things, so I can then look at the first stage of the solution. So let's flip the slide here. So clearly the name of this compound is sodium propanoate, the sodium salt of propanoic acid. And there I've also drawn the structure of 1 chloropropane. Drawing these structures certainly helps to make it easier to see the connections between the different molecules and what reactions we should be using and so on. Now, look at step 3. To get 1 chloropropane, you need to start with propan-1-ol. So that's why I draw structure C as propan-1-ol. And what do you need to react it with? It could have been any of SOCl2, PCl5 or PCl3, right? That'll do. You can even use zinc chloride in concentrated HCl with heating. Now then, we can simply connect the alcohol and the alkanoate ion path that comes from the alkanoic acid to deduce what the ester was to begin with, which was compound A. So now look at how we will move to that step here to look at the ester that involves this particular alcohol and the alkanoic acid, propanoic acid. So when we do that, we'll flip over here. There's the propanoate ion part, which involves the propanoic acid, and here's the propan-1-ol part of the ester. So the systematic name for an ester is alkyl alkanoate, where the alkyl part of the name comes from the alkanol. So this will be propyl propanoate. Right. So that's how we name that ester. And of course, how you break up an ester under alkaline conditions is to warm it up with aqueous sodium hydroxide or aqueous potassium hydroxide. The difference, if you did it under acid conditions, if you heat it up with dilute sulfuric acid, right? If you heat it up with aqueous sulfuric acid, then you'll get the alkanoic acid and the alcohol. Okay, remind yourself of these things all the time when you come across these reactions, so it reinforces it in your mind.
At this point, it is also useful to see why we can eliminate another possible option for what compound A could have been. Just like with esters, the salt of an alkanoic acid, this sort of compound here, is also produced when an amide is hydrolyzed by heating with a base such as sodium hydroxide solution. So, this could even have been N-propyl propanamide, this one here. So, that is a possibility that A could have been, but let's see why we can eliminate that as a possibility, why it cannot be the amide. Okay, now if you heat an amide with base like sodium hydroxide solution, in addition to getting the sodium salt of the alkanoic acid, the other organic product that you get is the amine that went into producing that amide. So, amine in this case will be propan-1-amine. But unlike with the propan-1-ol, propan-1-amine can not be converted in one step into 1-chloropropane. So, this eliminates the possibility of A being the amide, and therefore it can only be the ester propyl propanoate.
Right, now we need to see which compound you get here, C2E, when you react this primary alcohol with acidified dichromate ions. Clearly that's going to be an oxidizing reaction, right, an oxidation. And then that would either go to propanal or propanoic acid, depending whether you did it under reflux conditions or under distillation conditions. Okay, and then it can go in two steps through an in-between step to give you sodium propanoate. So that means the first product must have been propanal, which then with a further oxidation in reaction 4 converts the propanal into propanoic acid. And then you can just react the propanoic acid with sodium hydroxide to get sodium propanoate. Okay, so that's the plan. Now then, look at the next slide here where we'll identify this, draw up the structure corresponding to what I said. That's the oxidation of this to the alkanal. Why am I going to draw the alkanal, which is propanal, rather than propanoic acid? Because it has to go through another step here before we make something which is a propanoic acid that can react with sodium hydroxide to give us the sodium propanoate. So E would be propanal for that reason. So there we have propanal. Now, of course, I have to emphasize this further. You didn't need to do this because they had actually given you that, but to help you remember and distinguish these things, that's distillation conditions here to stop at the alkanal stage. If you reflux it, you will go all the way with the oxidation to the alkanoic acid, and that of course is propanoic acid. And if you react that with a sodium hydroxide solution, simple acid-base reaction, you get the sodium salt of the propanoate ion, which is this compound B. So that completes everything that this question asked you for. Any questions, please, anybody? If you wish to ask, no? Eduard's okay with that? Kiara, what about you? No? Great.